Alright. So y'all, I was just saying, we have this week, and then we have spring break next week. So, y'all have 4 days this week, Monday, Tuesday, Wednesday, Thursday, because most of y'all don't have classes on Friday. So we have Monday, Tuesday, Wednesday, Thursday to get through with, and then y'all have spring break next week. Okay, so y'all have no classes next week. So March 11th through 16th, March 11th through 16th, there are no classes. The school will be open, but I won't be here. I will send y'all an email to remind you of this, but the hub tutoring, which is right next to our hub classroom, they will be open, but they won't be open their normal hours. Normal tutoring hours are, and I think let me just snag it. Normal tutoring hours are, get it from right here. So normally they're open from 8:30 in the morning until 8:30 at night. They're open Friday from 9 to 3, and they're open Sunday from 2 to 6. But for spring break week, we give our tutors a little bit of a break on spring break week as well. So on spring break week, Monday, Tuesday, we're letting them stay open in the afternoon. Wednesday, Thursday, Friday, we're letting them stay open in the morning. And then Sunday are going to be regular hours. So we do have the hub tutoring room open. And y'all are only worried about 7106. 7106 is going to be the tutor room. You do not have to go to 7107. 7107 is the testing room. Y'all test with me. So if you're behind on your pipe, or if you just want to come in and do some work and ask some questions, or if you want to try to finish up your pipe, this is a good time to play catch up. This is like a free week. Okay? And it's just like going to Hub with me. You go in there, you sit down, you log in, and if you have a question, you put up your help sign. And they can help you with your calculator, they can help you with Alex, just like your tutors do when we're in Hub class. Exactly the same thing, girls. So, that is going to be next week. So we have today and Wednesday, and then next week, I won't see you. I will be at home doing my other job, but if you have questions and need me, send me a text. So if you want to work from home and you want to email me or text me by all means. Okay? Now, your schedule assessment 3, number 3 is going to be at the end of the month, but since we have a week off, that end of the month is going to come pretty fast. Hold on, let me find what day that is. Y'all's is going to be, this one ends up being April 3rd. So I did push it a little bit later because of spring break week. So schedule assessment 3 is going to be April 3rd. And that is when I want you at 75%. 75%. And I will tell you, this is one of the hardest months as far as your pie is concerned. Getting from that 50% to that 75% this month and next month are going to be your 2 hardest months. Because keeping that pie juicy. Because those knowledge checks come up and you think you're like, oh, I got a juicy pie, and then that knowledge check will knock you back. And don't wait till the end, y'all. I have so many of you who are like, oh, I'll do it at the end of the semester, or I worry about English or biology right now, I'll wait for it later. Don't do that. Stress is going to kick you in your butt. Go ahead and finish my class. That way you can worry about your other classes later. Knock my class out of the way. That way you don't have to worry about me. Get me done with. So that kind of gives you an idea of what's to come. This is the 8th week of the semester. So after this week, you are halfway done with the semester. That's why we want your pie to be at 50% or higher. So we have half the semester done this week, and we have half the semester to go. We good? All right, when we left last time, and we were doing this at the very end of the semester, so some of us were kind of brain dead, we're still in Module 3. We were talking about Pythagorean theorem. Now, on your formula sheet, let me grab my formula sheet again. On your formula sheet, I do have Pythagorean theorem written on your formula sheet. Right here. Now, the sad part is, the good thing is it tells you what Pythagorean theorem is, but the bad part is it doesn't tell you what goes where. So you're going to have to know that C is the side across from the right angle. So it's like you're standing in a boxing ring, okay? So if you're standing in this corner, the side that's across from you, that is your C. Your A and your B are like the rings that the sides that you hold on to. So if I'm standing right there, my A and my B are going to be the two sides that I hold on to, and my C is going to be directly across from it. We good? So, you always stand in the right angle. So if I stand right here, my A and my B are what I'm touching with my hands, and my C is straight across from it. So I don't care which one you call A and B, but your C has to be directly across from you. So I'm going to call my A 40 and my B 9. And my C has to be the one that's directly across from it. My A and my B are beside me. My C is directly across from it. And then I'm going to go to my calculator. And I am going to square my 40 and square my 9. And we did this at the end of the class, but not everybody was like feeling great about it. Oops. So I'm going to do 40 squared. I'm going to do 9 squared. So 40 squared is 1600. 9 squared is 81, and we still have my x squared. So since x is by itself, I'm going to clean both of these up. So what is 1600 plus 81? 1681. Now, the directions say that they want me to find x. I'm not done because this is x squared. This is not x. So to get x, what you have to do is you have to take the square root. Because a square root and a square cancel each other out. So to get my answer, I'm going to do the square root of 1681. So my square root button is right above my square button, and they're there for a reason. They are the opposites of each other. So 1681, the square root of that, there's my final answer. So x is going to be 41. X equals 41. But your C is in front of you, your A and your B are beside you. A squared plus B squared, add them up, and then take the square root to get x by itself. This is called Pythagorean theorem.
I actually used one of your videos over the weekend.
Oh, did you?
Yeah.
Good.
Is that the same thing as finding a
Perimeter?
Yeah.
No, we'll do one of those in just a minute.
Oh, okay. So is that
This is finding a missing side. And Pythagorean theorem only works on right triangles, because you got to stand in a right angle.
I think I printed the wrong one.
I've got them out of order a little bit. It's further back in those pages. All right, let's look at this one. A squared plus B squared equals C squared. So if I stand in the right triangle, in the right angle, what is my C? That's the most important.
15.
My C is going to be 15 because that's what's right in front of me. My A and my B are what I'm touching. So it's going to be x squared plus 15 squared. Yay? So I go to my calculator. Oops, that should be an A again. Keep it straight, look. You think you know what you're doing until the speaker starts writing. Okay, so I go to my calculator and I figure out 8 squared and 15 squared. So 8 to the second power is 64. 15 to the second power is 225. So I have x squared plus 64 equals 225. Now, we gotta notice that this problem is different than the previous problem. And I'm gonna scroll up for just a minute. Notice how the previous problem, x was by itself and the numbers were over here. Here, x is all up in the Kool-Aid. X is not by itself. So we've got to get x by itself, which means we've got to move him over. So how do you get that 64 over to the other side? Subtract. You got to move it by subtracting. You got to do the opposite. So this one requires one extra step. So we've got to subtract 64 so that we can get x squared alone. So in my calculator, I first have to do the 225 minus 64, which gives me 161. And I'm still not done. What's my last step? Take the square root so that those cancel. So my answer is going to be whatever the square root of 161 is. And the directions say round your answer to the nearest hundredth. So my hundredth is going to be 12.69. But just keeping up that C is directly across from the right angle, and you've got to pay attention. Is x already by itself? You add the numbers. If x is not by itself, you're going to have to subtract the numbers to get x by itself. And we're going to do a couple of these too, a couple more of these just to make sure you have them down. Because I have people say, when are we ever going to use this crap? This is one of the problems that you will use in real life sometimes. For example, this one says I have a building. I have a 16-foot ladder, and my ladder is 10 foot from the bottom of the ladder to the bottom of the building. I want to know how tall is the building. I'm not Superman. I can't crawl up the building. But I know that my ladder is 16 foot tall, and I know that I can measure on the ground. Do you see your right angle? Okay? Because we know that our building's not leaning, it's at a right angle. So I'm going to stand, pretend that's a person, stand right here. So if I use a squared plus b squared equals c squared, what is my c? 16. Whatever's in front, directly in front of me. So 16 is going to be my c. My a and my b are what I'm next to. So it's going to be x squared plus 10 squared.
You didn't know how you put it?
No, you could have done 10 squared plus x squared. Your a and your b do not matter. So I go 10 to the second, 16 to the second, so 100 and 256. So I have x squared plus 100 equals 256. Am I going to add those numbers or am I going to subtract those numbers? Subtract, because I've got to move that 100 away from the x. So x x squared equals 156. And I'm not done because they want to know what x is. So my last step is to take the square root of 156. And this time it says round to the nearest tenth. How tall is my building? 12.5. So I never left the floor, I never left the ground, and I know that my building is 12.5 feet tall.
You put square on there?
No, it's just plain, it's 12.5 feet tall. It's just plain.
Can I ask, where did the second power
When you're doing area. Second power is area, and third power is volume. All right, let me find, those are basically the same. Are we good with those? All right, here's another one that looks bad, but it's not as bad as it looks. This one looks awful, but it's not nearly as bad as it looks. We want to know how long is this missing side? How long is x? I was given every length here, and I was given every length there, and I just want to know how long is this side. Easiest way to do this, let me show you.
Oh, my God, all right.
Pick a number off the first shape. It's kind of like when we did proportions and I said miles over gallons equals miles over gallons. First shape over second shape equals first shape over second shape. So pick a number off the first shape. Any number, I don't care. 4. He picked 4. Who does it match with on the second shape?
2.
2. Pick another number off the first shape. 3. Who does it match with on the second shape?
X.
X. Now y'all did amazing, because what I usually have people do is they'll tell me 4 and 2, and then they'll tell me like 2 over, who does 2 match with? 1. And I would say, that was amazing, but we're supposed to find x, and you don't have an x in that problem. So y'all did amazing. You gotta have one fraction that has numbers, and one fraction that has an x, because you gotta have an x in the problem.
And you're gonna cross one.
And then you're gonna cross multiply
And divide.
and divide. So, you could have done that one. You could have said 2 over 1, but then you would have had to use 3 over x. You could have said 1 over 0.5, but then you also would have had to use 3 over x. So every problem would have had to have 3 over x, because you have to have a 3 over x in the problem. Now, just to show you, if I go to cross multiply, if I do the green problem right here, what 2 numbers would I multiply? 3 times 2, and divide, I'm going to do it all in one step, hold on. 3 times 2 divided by 4. What about the purple problem? What would I multiply, cross multiply? 1 times 3 divided by 2. What would I do for the red problem?
0.5 times 3 divided by 1.
Okay, for the first problem, do you see that I would multiply these two
Yeah.
and divide by that one?
Yeah.
For the second problem, do you see I would multiply those two and divide by that one?
Yes.
And for the last problem, do you see I would multiply those two and divide by that one?
But I thought we were just looking for.
We're looking for x.
Yeah.
But these are 3 different ways that you could have set up. So I'm showing you that if I would have done the first way,
Okay.
2 times 3 divided by 4. That's if I would have set it up the first way. Now, if I would have set it up the second way, I got the same answer. if I would have set it up the third way, I would have gotten the same answer. So it doesn't matter. I could have set it up this way, I could have set it up this way, and I could have set it up this way. I'm gonna get the same answer every single time, as long as I set it up correctly. You don't have to do all three of them. I'm just showing you that all three will give you the same answer. You just can't do it like this over here because you don't have an x to solve for. You can't cross multiply because there's no x. Let's do this one. So if I do first shape over second shape, Terry, you're giving me to look. Pick a side off the first shape
First shape of 4,
of 4. And who does it match with?
5.6.
5.6. So I don't care what you choose for that first fraction. But that second fraction has to be an x in it. Okay, so what is my second fraction going to be?
5.6.
All right, first shape over second shape.
First shape over second shape. Oh, okay. 4.
Okay, now if we
Once
do
again.
4 over 5.6, the question says find x.
Okay.
Do you have an x in your problem?
No, we don't.
We have no x, so I have nothing to solve for. So your 4 and your 5.6 is perfect.
Yes, first one, the second one.
So the second fraction, I need an x in there somewhere. So you're going to come over here and you're going to look at every partner. 4 and 5.6, I've already used.
Yes.
Can I use the 2 and 2.8? Does it have an x in it?
No, it doesn't.
Does that have an x in it?
No, it doesn't.
Does that have an x in it?
No, it doesn't. Yes.
So I'm going to have to use this
5.
pair.
Got to use 5.
So it's going to be first shape over second shape.
So 5 and X.
So my second shape that I have to use is going to be 5 over x.
Got you.
Now, I could have used 2 over 2.8. 2 over 2.8. But what would my other fraction have to be?
Over X.
5 over X. I could have used 3 over 4.2. But what would my other fraction have to be? 5 over x. Because you have to use that 5 over x so that you can have an x to solve for. But the first fraction, I don't care what you use. So, formula A, formula B, or formula C are going to give me the same answer. You only have to pick one.
Okay.
Now, when you cross multiply, you would either multiply those two and divide by that, multiply those two, divide by that, or multiply those two and divide by that. Now, you only have to do one of them, but I'm going to show you 5.6 times 5 divided by 4. 2.8 times 5 divided by 2. 4.3 times 5 divided by 3. Oops, that should have been a 4.2. I can't read my writing. Times 5 divided by 3. So it doesn't matter which one you do. My answer is 7, no matter what. It looks a whole lot harder than what it is. First shape over second shape equals first shape over second shape, and you have to use the partners that has an x in it so that you have something to solve for. So that has to be used no matter what. The first fraction, I don't care. Feeling good about those? All right, let's go to some easy stuff for a minute. Yay! Perpendicular and parallel. Parallel are like railroad tracks. They don't touch each other. They're like railroad tracks. And here's how I remember it. The two L's in parallel kind of remind me of railroad tracks. The two L's in parallel kind of remind me of the railroad tracks. Perpendicular crosses at right angles. So perpendicular means they cross, but they cross so that I can put a piece of paper in all four corners. Okay? So not only do they cross, but they have to cross at a right angle. So they have to cross so that I can put a piece of paper in all four corners. Now, if they cross and I can't put a piece of paper in all four corners, I call them neither. Okay? So, for the first one, I want to know, is that parallel, perpendicular, or neither?
Neither.
This would be neither because if I continue to make the cross, I can't put my paper in all four corners. So it's not perpendicular, it's going to be neither. What is this one going to be? Parallel. What is this one going to be?
Perpendicular.
Perpendicular. If you can put it in one corner, that means you can put it in all four corners. What's the last one going to be? Neither. So this one is neither. This one's parallel, this one's perpendicular, and this one's going to be neither, because when I bring it together, I can't put my piece of paper. Cool? All right. Segments, lines, and rays. A segment is a piece of a line. So it's like you took scissors. Oops, my scissors are going the wrong way. It's like you took scissors and cut off the two ends. It's like a little piece of a line. A line goes on forever in both directions. An array is like a little mixture. Think of a sun ray. Sun rays start at the sun and go forever. Start at the sun and go forever. Start at the sun and go forever. So you have a segment, which is a piece of a line. You have a line that goes on forever, and you have a ray that starts at the sun and goes forever. So when we look at these, they want me to say, is it a line, is it a segment, or is it a ray? So for this first one, what is that one? That one is a segment because I cut the ends off. That one's a segment. What is this one?
Ray.
That one's a ray. It started at the sun and went forever. What is this one? A line. So the first thing we have to do is we have to say what they are. That one's a segment, this one's a ray, and this one's a line. The next thing they want us to do is they want us to write it out. So, for the first one, we're going to write segment, F-E, or segment, E-F. Both of those, it doesn't matter how you write it. You got to put the little, there's like a little thing off to the side that you can choose. Now, I'm going to skip to the bottom one. The bottom one is going to be line AB or line BA. We good?
Yeah.
Now, the one that's going to get you is the one in the middle.
That one goes on forever.
Ray, CD. But if you write Ray DC, they're going to mark it wrong. Because Ray DC means it started at D and went towards C. This one doesn't matter because they're both arrows. So you can flip-flop. This one doesn't matter because they're both cuts. This one, the order matters because one's a cut and one's an arrow. So the C has to be under the cut. The D has to be under the arrow. So if you put it in this order, they will mark it wrong. Does that make sense? Because this is saying that D is there and C is there, which is not how we drew it.
I was looking at, I was just thinking about the X, I put in, I thought it was CD.
X.
Yeah, that's what I was doing. That's why I thought it was, I'll put.
X meaning wrong,
Okay.
meaning you're not going to get credit. Yay?
Yeah.
All right, this next problem, I'm gonna go to Alex and show you. It's not that it's a hard problem, but those of you who have done it realize it can be tricky. So let me pull up